Introducing Upsolver SQLake for database replication via change data capture. We can efficiently and continuously replicate relational databases to our data lake or other data stores for analytics. We can use this data to build reports and dashboards for ad hoc analytics or to feed data science models with minimal impact on the performance of the source database. In this example, we'll use a PostgreSQL database hosted on Amazon RDS. There are several prerequisites to enable change data capture for Postgres. If you need help with any of these prereqs, make sure to visit our Builders Hub at upsolver.com, where you can walk through an end-to-end tutorial. First, let's confirm that we have enabled logical replication on this database. We've created a user with RDS replication permissions. And we've granted select permissions for the tables we want to replicate. We're using the popular AdventureWorks OLTP database, focusing on the sales order header and sales order detail tables in the sales schema with which our analysts want to work. And we've created an Upsolver CDC publication for these two tables. We created a heartbeat table to insert heartbeats into the replication stream so that SQLake can frequently acknowledge change events. This will help Postgres avoid overutilizing disk. Our CDC user has access to this table, and we've added the table to our Upsolver CDC publication. Alright, now with the Postgres prep out of the way, let's get to the fun part. It's time to start building our change data capture data pipeline in Upsolver SQLake. SQLake is a serverless real-time data pipeline platform that makes it easy for anyone who can write SQL to build reliable and powerful data pipelines in minutes. While SQLake integrates with many data sources, the two most common ones we come across for change data capture are Postgres and MySQL. SQLake has numerous built-in templates for popular data sources, targets, and use cases to help us get started, including several specifically for Postgres change data capture. For this demo, we built our own from scratch. There are a few key steps we'll walk through. First, we'll connect SQLake to our source Postgres database. Second, we'll begin ingesting our database change events. Third, we'll transform the data. Our example here is pretty simple, but with SQLake we could write incredibly powerful transformations and execute them in real time with massive batch and streaming datasets. And we can handle issues such as time travel and adapt to schema evolution on the fly with ease. And then finally, we'll output our live tables for queries. Okay, let's start by connecting SQLake to Postgres. We can create a connection once and then repeatedly use it to connect to our source. And just like that, we can see our new Upsolver Postgres connection in our left nav, and the log on the bottom center says SQLake successfully created the connection. Now it's time to create a staging table in SQLake. SQLake will use this staging table to store raw CDC events for all our replicated tables in a single append-only wide table. This table includes a system column, full table name, that we will use to partition the staging table downstream. With multiple source tables, this will make it more efficient to retrieve events for selected tables. This raw events table also lets us time travel and reprocess past data when we need to. In our case, we already have the worksheet ready to go, but it's worth noting that SQLake will help us auto-complete our SQL as we type, or we can click on the plus button to add a snippet with placeholder values. Now let's create the ingestion job that will bring our raw change events from Postgres into our staging table in SQLake. We'll use the publication name and heartbeat table we created in Postgres. While the table include list includes each table that we want to replicate, we could use the column exclude list to ignore specific columns, such as those containing PII. SQLake immediately displays both our job in the left nav and a note in the log in the bottom letting us know that the job was successfully created. We're using sync jobs in many places in our CDC pipeline. Sync jobs are unique to SQLake and enable data pipelines to self-orchestrate, so jobs are always in sync and data remains consistent without manually building or maintaining any DAGs. When the job initially runs, SQLake will take a snapshot of each of the tables we're replicating. After SQLake is finished copying the historical data, it will start streaming CDC events. We can monitor the status of the snapshot and streaming process with the Job Properties window from our connection list. But once the snapshot is loaded and data is streaming, we can run a quick query on our staging table to ensure everything appears as expected. So far, so good. Let's see how many rows we have by table in operation. Awesome, we can see all the tables we included in our publication. Looks like the bulk of our data was in the snapshot, which we expected since this was a static sample database. All of the updates are from the heartbeat table. So now our staging table contains a raw copy of all the tables we selected to replicate. It includes rows from the initial snapshot, and if this were live streaming data, all change events since. We are replicating two key tables from our database, so let's create two tables to separate them out from our staging table in SQLake. We'll create a primary key as a concatenation of all primary keys in the source table. SQLake uses this composite key to merge inserts, updates, and deletes on the output tables to keep them consistent with the source. And now we can create jobs to run every minute with some fairly straightforward logic to insert, update, or delete rows into the output table for each CDC event that SQLake ingests. SQLake will use the primary key column to identify identical rows between the staging table and the output table. Essentially, we've joined a few tables from Postgres in our CDC data pipeline, and now we're going to run jobs in SQLake to separate the tables back out. If we wanted to perform any transformations, rename, remove, or add computed columns, we could easily modify the select clause to do so. Let's run a simple select star statement to make sure everything looks as expected. Perfect. Now let's go ahead and create a similar job for our other target table. Everything looks good here as well. While in this demo we output the tables directly on SQLake, these could have been output to our data warehouse, query engines, or other systems. Alright, that's it for our demo of Upsolver SQLake for database replication via change data capture. Try it out for yourself. Head on over to upsolver.com to sign up for a free, fully featured trial of SQLake, and then stay on board for $99 per terabyte of data ingested with no minimum commitment. That's the power of SQLake for change data capture.